Welcome again to our series on chi-square statistic. The last time, this is where we stopped. We got our summation. So this is the value of the chi-square. So let's say if you were the student and at the end of the all right, so let's say you had finished with this. Okay, so all we needed to do is just have our chi-square equals to then we have our 155. So forgive my writing, I'm not using a touch. So using the mouse to write is a little difficult. Well, all I wanted to write is just this one here. So your chi-square value here is what we need to use to now compare with the table value. How do we get our table value? I downloaded the table value in here so we can use this one to do the comparison. But before we come back to the table, we need to know a few things, or we need to get a few things before we go back there. One is the degree of freedom, which we call the DF for short. Then the second is the probability value, that is your alpha value. Okay, so how do we get our degree of freedom in this? Now, for contingency table like this, we consider the number of columns and the number of rows. So in this case, we have three columns. We don't add the totals in the columns when we are counting the columns and rows in this case. So we count only the categories. So we have three columns in this case and two rows. So this is how we get the degree of freedom. We subtract one each from the row number and the column number. So in this case, we have 3 minus 1, that is for the column, and then 2 minus 1 for the rows. So we now multiply the two of them. So 3 minus 1 multiplied by 2 minus 1. That will give us the degree of freedom. So we have 3 minus 1 multiplied by 2 minus 1. And we know 3 minus 1 is 2, 2 minus 1 is 1, which will give us 2. So our degree of freedom is going to be 2. Now, as I said earlier, we are going to consider the 0.05, the 5% that is mostly used. I'm not saying it is a must or it is a standard that you use the zero point 0.5. It depends on the kind of analysis you're doing. Let's say, for example, if you're doing this kind of analysis for a medical practitioner, or let's say you have medical data, something that has to do with life, I definitely won't recommend you using 5%. Okay, so that would mean that 1 out of 20 you will get a mistake, and you cannot be doing that to human population. All right, so because it's just for educational purposes and to educate you on how to use it, I am still going to use my 0.05, which is the same as 5% error margin, to demonstrate our calculations here. So right now I'm going to get the table value. Okay, so we could get it here, but let's go to the table and then find out about this particular one. So 0.05 as our probability value, and then our degree of freedom is equals to 2. So in here we're going to have, we are looking for 0.05. So this is 0.05, and the second one I am looking for a degree of freedom that is equals to 2. So the way you read the table is you look at the column where 0.05 is, and you look at the row where the degree of freedom is, and then you trace it up. Okay, like this. This is the degree of freedom equals to 2, and then this is our alpha value equals to 0.05. So where the two meets, and I believe is this number here, 5.99. That is the value we take as the table value. So we're going to come back here and say that our the table critical table value let me put table for short, is equals to 599. So is equals to 5.99. So we are comparing this value. I'm taking off the ink here. So we're going to compare this value to the 5.55. Now the decision will be if the value we have calculated, which we are going to call the chi-square statistic value here, if it is greater than what we have read in the table, then we have every reason not to accept the null hypothesis. So in plain language, I'm not saying use this directly, but for us to understand and for our beginners who are in this class, if this value is greater than what we have read in the table, then reject the null hypothesis. So, what is the null and alternative hypothesis? So, let me say here our null hypothesis. Let's denote that by H0 or H0, and this is H1. Okay, so the null hypothesis is simply looking at no association. Okay, so it means there is no relationship between gender and the position that the person occupies. So the performance of the firm. So in this case, we did not actually have a perfect question. We just um, put up this contingency table just to demonstrate. But in actual fact, we could have been looking at, let's say, all these ones are good performances. And now we want to look at the male and female, the good performance of the firms. Does it have anything to do with whether the male or the female occupying a particular position? Okay. So here we say no relationship, and the alternative says that there is a relationship. So there is association. So something like that. Now, if there is no association, it means that knowing the outcome of any of these do not have anything to do with the position occupied. However, if we are going for the alternative, it will mean that knowing the outcome for gender definitely has something to do with, or let's say gender is dependent on position, or position is dependent on gender. So knowing the gender of a particular person and the position the person occupies has something to do with the performance of the company. So that is what we probably would conclude. Now, here, as we said earlier on, we are rejecting the null hypothesis that says no relationship at the 5% level, since the chi-square statistic that we calculated is greater than the table value that we read. So this is one way of doing it in the manual process. Now, we could have calculated these um, expected values, and knowing our observed values, we just ask Excel to give us a p-value so we can make a decision instead of going through all these uh, calculations. However, these calculations are good for you in terms of the exam purposes. All right, so I'm going to now arrange these in a way that Excel can help me uh, give me a probability value without me having to go through all these ones. So let's have two columns. One we call the observed, and the other one we call expected. Okay. So I'm going to just copy this and transpose them right here so that we can use them in that. All right. So here I'm going to have to go to my home and paste as, then it to the columns, and the second one the same thing. A special. Oh, sorry. I want to transpose it so that it will be in one. So it means this one we have to do them the same way. So I just want to copy them and paste as values. I don't want the formulas to follow me. So copy this, command transpose it here. Now copy the second row, command transpose it right there. transpose. Okay, so this is what we're going to work with right now. So using the inbuilt formulas that Excel has, we can try to get a p-value that will help us make a decision just like we did here. And that particular formula, we already saw it before. So we have the chi-square, the last one here, test, chi-square test. So you can see as I started typing the list of formulas that are similar or that starts with this, they all start populating down here. So all I need to do is just click on the one I want and press my tab key, and the typing is complete. Now you can see here the first in the syntax is the actual range. Okay, so that is the observed range that we're looking at. That is the same as the actual range. Now the second one is the expected value, which we calculated already. So we need to put a comma, then we select the second part, which is our expected. We close the bracket, press your enter key, and then we have this value here. Now, this is 1.12 plenty numbers multiplied by 10 to the power negative 31. So it means I am going to have, if I want to write it in full, I'm going to have 0.00030 of them. Okay, 30 zeros. Okay, before I get to a 1, 1, 2, 8, those numbers. Okay, so literally the p-value here is equals to 0, because this is very, very, very small. We cannot simply see this one with our eye, so it's very small. So we can say that the p-value here is very small, and comparing this with 0.05, which you have here, this one that we have calculated is way far less than our p-value. Now, the decision here is different from the decision that we made earlier on. Let me state that again. The decision that we took earlier on said that if the chi-square value that we calculated, the sum, is greater than what we read in the table, then we reject the null hypothesis. When we come to the p-value, it is the reverse. If the p-value is less than what we state here, the margin of error, then we reject the null hypothesis. So you can get confused here. Okay, so you need to be very careful when using any of these, because you can get confused and consider one interpretation as the other. So using the p-value procedure in this form, this is all we would have done. So we only needed to calculate the expected values, bring it in this form, and use Excel chi-square test formula to get our p-value, and now compare that with the margin of error that we have chosen for ourselves. And based on these two, we say we are rejecting the null hypothesis and going for the alternative, which obviously says there is some kind of relationship between gender and the position that the person occupies in terms of the firm performances. So basically, this is how we can use Excel. One of the ways we can use Excel to actually come up with a chi-square statistic and make a decision out of it. I hope this is helpful, and I will see you in another video.